If k is an integer greater than 1, does k equal 2? Statement 1 tells us that a and b are any two positive factors of k, where a is not equal to b, and a minus b must be odd. So the interesting thing about this is that a minus b must be odd. That actually narrows things down quite a bit for us, because we have to be able to have the difference between the two be odd no matter which two factors we pick. So if we pick a number like 9, whose factors are 1, 3, and 9, 9 minus 3 gives us 6, which is not odd. 3 minus 1 gives us 2, which is not odd. And 9 minus 1 gives us 8, which is not odd. So clearly we can't have an odd number because we won't have a difference between the two factors being odd. Let's try an even number, like 4. If we choose a number like 4, the factors are 1, 2, and 4. So 4 minus 2, that gives us an even number. So already we've found two of the factors that don't have an odd difference. 4 minus 1 is 3. That one is odd, but again, 4 minus 2 ruined this one for us. 2 minus 1, however, is odd. So basically, it must be the number 2, the only two factors of which are 2 and 1, the difference between which is odd. So by process of elimination, any even number larger than 2 will have one pair of factors that will not have an odd difference. An odd number will never have an odd difference between the numbers, so it must be 2. So statement 1 is sufficient to tell us yes. We get rid of B, C, and E. Statement 2 tells us that K has only two positive factors. At first that may sound promising because 2 itself has only two positive factors, and we just figured that, but really all statement 2 is telling us is that K is prime, which in almost all cases is going to be an odd number. So it's a number like 7, the factors of which are 1 and 7. The difference between 1 and 7 and 6, 1 and 7 is 6. And then K does not equal 2. Whereas if K does equal 2, the factors of which are 1 and 2, then it is. So statement 2 on its own gives us the infinite number of prime numbers to choose from, only one of which is yes for k equals 2. Sometimes yes, sometimes no is insufficient. So answer choice A is the right one.